So in today's lesson, we are going to review what we have seen in Module 9, which is alkanes, alkenes, alkynes, move on to new concepts which have to do with reactions of alkanes, alkenes, alkynes, cycloalkanes. We don't have a lot left in this module, so hopefully we'll wrap those up and move on to 10. Okay, so we'll review. Alkanes, alkenes, etc. Alkynes, cycloalkanes, cycloalkenes, meaning name and reactions. We've done like maybe 3 lectures of naming, but we haven't seen any reactions. And then maybe we will move on Module 10, sorry, which is alcohols. Not necessarily in that order. I'll look at your faces, and if we're ready for reactions, then I'll move on to there. Some people think that naming alcohols is easier than reactions, so we'll see how it goes. If I ask you to name this example, page 156, I'm going to strip the carbons from the hydrogens. If I ask you to name this compound, name this compound. In a test, of course, the H's will be there. So you have 3 H's here, 2 H's there, 2 H's there, no H's there, 2 H's here, and 3 there. And you may want to remove them if that's going to confuse you. Okay? If I ask you to name this compound, and the first thing is we're going to find the parent chain. Okay, and the parent chain then needs to be numbered. And then we're going to put whatever we have in alphabetical order. And in this particular example, we don't really have much, so we don't even have a rule 3. So many times we only have rule 1 and 2. We have rule 3, we have many substituents, and then they need to be named alphabetically. But if we don't have many substituents, okay, so I want to know how many carbons in the parent chain. I hear 5. I hear 6. I hear 4. The minute you do your homework, you will not have these doubts in your head, is my point. And I hear a lot of people writing 5. Where are the 5s? Let's do the 5s in blue, maybe. Where are the 5s? These 5s? 1, 2, 3, 4, 5? That's one choice. That's that. Where are the, what else do you have? How do you find 6? 6 will be those 5, and somehow you go up there. So some answers are crazy. That's a parent chain cannot have a branch. A parent chain was the longest continuous chain. That is not continuous. Okay, so whatever you're doing wrong, and you're not going to do everything right to begin with, you will learn as you do things, as you get exposed to new homeworks. And then whatever's wrong, it'll be cleaned up. That's the way it works. So is 6 a good answer? No. Okay, the parent chain must be the longest continuous, not branched. Branched is not acceptable. So the longest continuous chain is what I want So, okay, so we tackle that answer. What about 4? Who said 4? Where are the 4? Who said 4? Go. Starting on the top? I'm going either left or right. So this would be 4, and that is the best answer. Okay? So when you find the parent chain, whatever goodie you have, if it's a chloro, if it's an alcohol, if it's a double bond, if it's a triple bond, that's going to be having a spotlight. And that parent chain must bring it. Okay? So the parent chain, I'm going to add to that concept. Okay? I'm going to write it down so it clicks. Find the longest continuous chain containing, you have a double bond here. The double bond. And again, when I say double bond, don't limit yourself to double bond, because in some examples you're going to have a triple bond. Okay? Before we had a cyclic compound, and then the parent chain contained the cyclic compound. So whatever feature you have in there must be part of your parent chain. Okay? And then once you find it, so this is my parent chain. This cannot be parent chain because it doesn't contain the double bond. So it's going to contain, today we're going to sprinkle in there other things like alcohol groups, and your parent chain must contain the alcohol group, the OH group. Up to now we've just had parent chains trimmed with methyls and ethyls and propyls and chloros and bromos. And then you number the parent chain so that what? The double bond gets the lowest number. So if the double bond is not part of your parent chain, you can't even address module rule 2. So you number the double bond so that the blank gets the lowest number, so that the methyls get the lowest number, or the chloros get the double number, or the double bond so the triple bond gets the lowest number. So I start from the top. Very good. So I'm going to make it red. 1, 2, 3, and 4. So we can't review enough. There's always one more example that's going to go like, oops, now what do we do? And the more you work, the less of those oops will happen. On the day of the test, we'll have no oops. That's what you're shooting for. And after you do that, you realize that that's a branch. And a branch of 2 is called an ethyl. And it needs an address, and it's carbon 2. So now that you have a parent chain, and your parent chain was this one, what do you call the parent chain? You said that this was a 2-ethyl. And it's not writing the 2, but we're going to write it up there. And the parent chain is what? I'm sorry? It's butene. And what's wrong with that one? We're missing something. Butene means you have a double bond, but I need to position it. I have 4 carbons. Where do I sprinkle that double bond? 1 butene. Do you understand what I'm saying? We've got to dot every I, cross every T. So what's this fellow's name? 2-ethyl. A little dash between the 2 and the ethyl. Okay, so numbers and letters are always separated by dashes. And then it's at 1 butene. Yes? Okay, when I have a double bond, and I have in the double bond, the carbons that have the double bonds, which I made and write, have 2 different substituents. Okay, and in this case I have different substituents in there. A fluoro and an H and a fluoro and an H. When I have that example, and when I have this example, I'm going to swap these 2. The F is going to go down, and the hydrogen is going to go up. This substituent is different than that substituent. These angles, when you have single bonds, all of those angles are 109.5. But when I have a double bond, the angles are 120. So a 2-dimensional piece of paper, which you're using to write your notes, or what you're looking at in the screen, that is a perfect medium. These are 120, and these are 120, and these are 120. This is a triangle. So this fellow that has a double bond, I'm going to make a plane like the equator, north and south of the equator, where my double bond is. If on the top of my plane of symmetry I have 2 fluorines, or if I have 1 fluorine above and 1 fluorine below, those are 2 totally different compounds. And this, you are right, this is the cis isomer, and if it's a cross, it is the trans isomer. So name these guys. These compounds are, let's baptize them. What's the first one? Cis is part of your name. Cis what? 1,2, what? Difluoro. I have 2 fluoros. Difluoro, what? Well, for ethene, the double bond can only be between carbons 1 and 2, so I don't put a 1. Okay? And this fellow would be the same thing, only trans. So this is the trans isomer of it. So when do I have cis and trans isomers? These are geometrical isomers. When I have a double bond, and in this case I have that, and each carbon of the double bond, you ask yourself, besides the double bonds, if carbon has a valence of 4, you have 2 more substituents. And if one substituent is different from the other one, and that happens in the second carbon as well, one substituent is different from the other one, you will have cis and trans. In my previous example, this carbon that has the double bond, does it have different substituents? No, it has 2 H's. So this guy will have no cis trans. If H is identical to H and you flip them, what you put to the right you're going to put to the left, or what you put in the top you're going to put in the bottom, that's not going to make a difference. Okay, so in order for us to have cis and trans isomers, and these are geometrical isomers, we need 2 conditions. We need to have an alkene, we need to have a double bond. So you 0 on that double bond, you put your attention in that double bond, and you realize that those carbons in the double bond has a valence of 4, are going to have 4 bonds. Of the 4, 2 are taken for the double bond, and the other 2 need to have different groups attached to them. Okay? So if I have, I'm going to ask you to name something else for me. Name this one. Find the longest continuous chain, and again I'm stripping them from the H's, and maybe I shouldn't do that because your test will have all the H's. Okay, and it's the same 2 rules. Find the parent chain, meaning the longest continuous chain containing the double bond, or the triple bond, or whatever you have. In this particular case is a double bond. And then you number the parent chain so that your ethyls, your chloros, your double bond, your triple bond, whatever your compound's bringing, gets the lowest number. Okay, so how many carbons in the parent chain? Go. What is the name? And I'm not going to walk you. You walk yourself, you name it. Tell me. What's the name? Anybody? Butane. The name is butane. What else? What other answer do I have? The name is trans. Okay. What other name do I have? These are parts of thoughts. Those are not the names. The name is, this is the name. The final McCoy. What is the name for this guy? Butene, I hear. I'm going to write everything I hear. Okay, and this is what you do when you're just learning. You're just going to get little pieces, and then you have to put it all together. We need to get the whole picture. Okay, I heard a name that sounded like something. Trans, I'm sorry? Trans 1,4 difluoro, almost difluoro. If I say butene, thank you. Very good. 2-butene. So what did this person do? Found the parent chain. Is that news for anybody? The longest continuous chain. And it's not going to be straight. It's going to be continuous. This is a continuous chain. And then after you find it, everybody else that has not been addressed needs an address. Needs to be addressed, and they need a number. So you need to number the parent chain. And when you number the parent chain, you're going to go 1, 2, 3, 4, yes? And my double bond is between 2 and 3, so that's why I have a 2-butene. That means double bond between 2 and 3. And the fluoros are in carbons 2 and 3, so I don't like these 1 and 4. That's the only thing that I don't like. So what? Let's fix that one. It's what? 2, 3. So the fluoros are in 2 and in 3, not in 1 and in 4. 1 and in 4, this is carbon 1 and this is carbon 4. So these two rules, finding the parent chain and numbering the parent chain, this is like lecture 3 or lecture 4. We're saying the same thing. Okay, so the correct answer, I had a 1-4 there before. That's not what I want. The correct answer, I'm going to write it again. Tell me, trans, what? So trans is because these two are at opposite sides of my equator, my plane. Okay, so I make analogies to whatever it is that you may grab onto to get the point. Trans 2,3 difluoro 2-butene. This guy needs to go through life with this name. And you were going to tell me if I have CH3, C, C, H, H, H. What's this guy's name? Can we see there? The name is propane, and I'm going to do the exact same thing. And then you're going to find out what it was that was wrong of that name. 2-propene. 1-propene? Does propene need a number? Did ethene need a number? Why didn't ethene need a number? Because the double bond can only be between 1 and 2, because that's all you have. Does propene need a number? So what is this guy's name? Propene. No number. Okay, so whatever you're doing, get exposed to different examples, and you'll learn something else from each one of them. It's called studying. Okay, so you don't need a number. You do not need a number. Another name. Do I have cis strands there? No, why not? Because this carbon in the double bond does not have different groups. In order for me to have cis strands, and if you didn't hear that, write it. Because I say a lot of things, I don't write a lot of things. We're doing videos because that will record every statement I make. But some of you are still sleepy. We need another cup of coffee, and I need one myself. I said that in order for us to have cis strands, isomers, each carbon in the double bond, you first have to have a double bond. And every carbon in the double bond have what? Different groups, non-identical groups. And an H is identical to another H. So that is not going to give me a cis trans. This guy makes the cut, but this guy doesn't make the cut. So there's no cis trans. No cis trans. Another name, and then we'll move on. What's this fellow's name? And I'll write everything I hear, and then we'll discuss what's wrong with each one of your answers. 1-ethyl. I hear this. I hear cyclopentane. 1-ethyl What's wrong with pentene? That's a continuous chain of 5 with a double bond. Do I have that? So is that a good answer? So you write whatever it is that comes to your mind, and then you analyze it. And then if it's not right, we learn something from it. Okay, it takes a little time, but it works. What's wrong with the second one? I want another answer because I still don't like it. 2-methyl, okay? Pentane. Oh, we changed our minds. Cyclopentane. So notice what you're doing. The term cyclo is being forgotten. So make a note. I forget the cyclo. I need to pay attention to the cyclo. So the day of the test, I don't make that mistake. Okay, I'm teaching you like I taught my daughter and my son. This is how you walk. And then they would fall. And this is what you do. You don't trip. And we go little baby steps until you master whatever you're teaching. I still don't like any of these. Do I need a number here? If the methyl is there, or the methyl is there, or the methyl is, it's going to stay there. The methyl is here. What is this guy's name? Do we remember the Ferris wheel? Do we remember that these guys are not stiff like your paper indicates they are? Do we remember to think in a nice three-dimensional way? Do I need a number? So if you don't need a number, like I didn't need a number in 1 ethene or 2 propene, I didn't need that. Because the double bond is only going to be between 1 and 2. I don't need a number here. So what's this guy's name, guys? I need the methyl. I don't need a number for the methyl, but this guy is not cyclopentane. This methyl cyclopentane. Okay? Yes? Questions so far? Enough naming of good old people?
If we put a 1 though, it's wrong.
It's wrong. Names are very black and white. Your name is either Peter or it's not Peter. It's not kind of maybe Peter. Cannot get partial credit. I know that's your next question. Can I get partial credit? Not happening. Your name is what it is. And we're learning how to name correctly. Not halfway there. Thank you. I think I'm going to move on to alcohols. I don't want to go to reviewing, doing reactions, because it's more of the same thing that we're doing. And you guys are still sleepy, and I need your being awake by reactions. Yes. This is the name of the previous one. The last name you gave me. I'll keep on asking for more and more. E would have been none of the above. Or I don't care, yeah. Or like, who knows? Okay, it'll be a crazy answer. Okay, so we understand that this is like a Ferris wheel, and whatever's on the top, for 1 second, they're vibrating inside a flask. And whatever's on the top is going to be on the bottom, just like you are the same whether you put your arm up or down. You didn't change into a different person. But if they take a picture of you, this is a different picture than that. That doesn't mean you're a different person. Yes? Not so bad? Okay, so what do we do? Alcohols or reactions? I don't know why I'm asking, but... Alcohols, I think it's easier. So let's move there. Because we're still going to drill those same 2 rules. That's all I've given you, 2 rules. And this is again and again and again. I don't want you to forget those 2 rules. If I have a hydrocarbon chain with an OH group, hydrocarbon chains with an OH. So instead of having a chloro or a bromo or a methyl or an ethyl, I have a single bond OH, which is called a hydroxyl group. Thank you. An OH group. Did that come in? No. So I can only write yes? So if my OH is here, or if my OH is here, those are alcohols. And what is the name? If I didn't have an OH, what would this fellow's name be? Name ends in ol. So instead of methane is going to be methanol. Instead of ethane is going to be what? Ethanol. Instead of propane is going to be what? Propanol. Instead of pentane is going to be what? Pentanol. Okay, so those first 10 must be in your head because I'm putting another layer on it. And I have many more layers to put in. So don't fight it because they're not going to stop coming just because you don't want to do your homework. But what else do I need in here? I find my parent chain, longest continuous chain that has that carbon that brings that OH group. Now that gets the spotlight. And now I'm going to number it so that the carbon that has the OH group gets the what? Lowest number. I can go right to left, left to right, top to bottom. So what do I call my first one? This guy's going to have 2 H's and 2 H's and 3 H's. This guy's going to have 3 H's, 1 H. What do I call my first one? Ethanol has how many carbons? F. F means 2 carbons. Prop means 3 carbons. Bute means 4 carbons. Ethane is 2 carbons and nothing but single bonds and H's. Ethene means 2 carbons and a double bond. Ethyne means 2 carbons and a triple bond. Ethanol means 2 carbons and an OH group. Does this have 2 carbons? Because I see 3. So what is it then? Propanol needs an address. So it's what? 1 propanol. Do you see the resemblance? We're using International Union of Pure and Applied Chemistry. Nothing different. So if that's 1 propanol, what's this guy? 2 propanol. What about if I have this fellow? 1, 2, 3, 4. Is that still an alcohol? Yes. So we're out of alkanes, out of alkenes, isocycloalkanes. We're in module 10. And these are alcohols. This is, a lot of these are disinfectants and you put them if you hurt yourself. Isopropyl alcohol. This actually is isopropyl alcohol. This is rubbing alcohol on your screen. You want to name me? Name him. Go. Find the parent chain. Longest continuous chain. Go. So what do we call this fellow? Find the parent chain. Who need to do that? Find the parent chain, frame it, whatever's not there, circle it. Everybody needs to be addressed. Okay? Like this guy won the lotto, and it needs a complete name. Otherwise, somebody else is going to claim it. That's my parent chain, right? The carbon that has the OH group is in there. But who's not addressed? This carbon. Okay, so you can write your H's. Now name it. 2-methyl. Thank you. 2-propanol. And we don't need a B and a C and a D because this is a good answer. You will learn the minute you just do those 2 rules. That's all I'm asking. Find the parent chain and number it. Does that sound like a new thing? No. And I don't care if I have a chloro, I'm going to name it so that the chloro gets the lowest number. Or if I have a double bond, I'm going to name it so that the double bond gets the lowest number. Or if I have an alcohol group. And I'm going to sprinkle many other things besides double bonds and triple bonds and alcohol groups. Okay? Name this guy right here. 1, 2, 3, 4, 5. Name this guy, and I'm stripping them from the hydrogens. Okay, so we're naming alcohols. Find the parent chain. Who's the PC? Number 1. So catch yourself. Am I finding the parent chain? Longest continuous chain that has what? The carbon with the OH group. That carbon is important. It's bringing a big deal. And the properties of this compound, they're going to be disinfecting and because of that carbon. So you cannot ignore that carbon. He's a head honcho. And then you number that parent chain so that the carbon that has the OH group gets the lowest possible number, period. 1 and 2. Find it and number it. How many carbons in my parent chain? Where is it? 5. Which 5? These? These 5? 6. Where do you go 6? Start from the end and then down. Both of those methods include this guy. This guy must be included. What's wrong with which one? The word longest means if you get more carbons, that's a better answer than if you get less carbons. So it's like an auction. So which one is it? So these are the things you could do wrong. Fix them. Okay, so we found the parent chain, so what we need to number it. And how do we number it? Who's carbon 1? This carbon here. 2, 3, 4. Do we understand the 2 rules? Yes? We can move on from these 2 rules? Okay. So go. Name it. Put it all together. What's this guy's name? Baby. Methane has how many carbons? 1. Ethane has how many carbons? 2. So ethyls has how many carbons? 2. Methyls have 1 carbon. Ethyls have 2 carbons. Propyl has that series of 10 alkanes that I gave you 2 weeks ago. Don't fight it. You're not going to move forward until they're in your head. It doesn't work any other way. There you go. 4-methyl, 2-hexanol. Very good. So that is, are there any questions in here? Okay, so we had a little parenthesis there for alcohols because I need for you to learn these 2 rules. Okay? Yes? Okay, I am going to move to reactions of Module 9 of alkanes. And again, the great majority of you got these 2 rules. Not everybody. Some of you are still frowning. But the great majority of you are okay now, I think. If you know how to name these people, you know that you need to address 2 rules. And the rest of you will learn it today, hopefully. We're going to do reactions of alkanes, alkenes, etc. We're back to Module 9. So at the beginning of every module, in the organic section, 9, 10, 11, you're going to be naming a new category. Okay, but numbering the parent chain and finding the parent chain is going to be consistent with all of these modules. It's the same thing. If you have a carbon with 4 hydrogens, you can show the structural formula, showing all the bonds, or you can show the molecular formula. For reactions, this is your strategy. Show the bonds. Okay, for naming, find the parent chain. Can't name it without finding that. For reactions, show not the molecular formula, with the structural formula, showing every bond. That's your strategy. Your tests are going to not come that way, but you're going to translate them. If I give you CH4, you write the C with the 4 H's. If I give you Cl2, you're going to write Cl and Cl. And actually, you could write Cl and Cl in a different color to get the point. So show the bonds. I want you to show all bonds. And to do that, you just need to know that carbon has a valence of 4. When methane reacts with Cl2 in the presence of light, you can heat it up, or you can put H nu means energy. This bond, or that one, or that one, or that one, because they're all tetrahedrals and they're all identical, correct? You switch your partners. And the Cl goes there, and the H goes there. So what you're going to form is CHH what? Cl. And HCl. That's called halogenation, because you're adding a halogen. Okay, so now I am baptizing it. Halogenation. Chlorine is a halogen, bromine is a halogen. Do we remember that? So halogenations of alkanes is what I have on the board. How would you condense this? What do you write here? CH3Cl and HCl. That's green? Didn't mean green. Whatever. What about if I give you this? CH3, CH3, and Br2 with some energy. What do you write? Is that a different reaction? Who are the halogens? Group 7. So what do I write? And this is what I want you to finally give me. But this is where you start thinking. You show all bonds. So what do you do first? Show all bonds means don't hurry. Show the bonds. Like Jerry Maguire, show me the money. Well, show me the bonds. Show me them. Because you're not going to follow it until they're in front of you very, very obviously. Okay, so you go from here to here to here to here. Your final answer will be condensed, but you're seeing the bonds and swapping whatever you need to swap. This is a substitution reaction. So what do I have? Does it matter which carbon I substitute? Makes no difference. Okay, so you pick. You want to pick this one right up here? Or this one right up here? It doesn't matter which one. And HBr. So what do I write? And the final answer was in green, so it's what? CH3, CH2Br, and what? HBr. Not so bad? It doesn't matter which one. They're all identical. You can pick any one of them. They're all identical. So you go back to Module 9 with that little tetrahedron of carbon, whether you brominate and you put the bromo here, 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 they're all identical. Makes no difference. Okay. What about if I this is an old one. Combustion. Let's say if I have this CH4 and O2. What are my products? CO2, very good, and H2O. And then you balance the way we've always balanced. So that is old. I'm not even going to spend any time in there. You must now complete it. In the past, I didn't have anybody there, but we used many people as examples. Okay, so we have C3H8 and O2. Who do you form? CO2 and water. What about if I have C5H12 and O2? Who do you form? CO2 and H2O. What's going to change? The balancing. And to balancing, you look at your carbons, then your hydrogens, then your oxygens. So that's homework. Balance these guys, so they're not balanced. With the combustion, it's not new. It's old. Okay, so combustion is any hydrocarbon, CXHYOZ. Because in a minute, we're going to have alcohols burning. And they have oxygen in there. And when they react with oxygen, they form carbon dioxide and water. Always carbon dioxide and water. Okay. I'm going to go to addition reactions of alkenes, and alkynes are going to be identical. The first one, halogenation, I said it, but I don't think I wrote it. It's not an addition. This was what was it? Substitution. Very good. Okay, so sometimes I say things and I don't write them. Hopefully you're writing them, everything I'm saying. So we've seen substitution, we've seen combustion, and now we're seeing what? Addition. Addition reactions. If I have an alkene, I'm going to give you the simplest alkene. Give me an alkene. Simple alkene. And I'm going to show all bonds. And it may come to you that way or not. Okay, I may give you this. CH2, CH2 plus H2. And what do? If you want to show all bonds, you show all bonds. And you have 2 carbons, and guess what? Every carbon has 4 bonds, and one of them must be a double bond, because every one of them has a what? An H and an H. So that's step 1. Show the bonds. Did you hear that? It looks very different when you don't show the bonds. Now I want you to think that you are going to the Keys and there's a bridge. Let me make that red. There is no red bonds and blue bonds. I'm trying to make a bond. So whenever I have a double bond or a triple bond, I have unsaturated hydrocarbons. Saturated hydrocarbons have single bonds. Unsaturated hydrocarbons have double or triple bonds. That double bond, which I'm writing in red, can open up. Just like a bridge will open up. Okay? And when you open it up, this carbons, besides the 2 H's that they already had, so I'm showing what they had, this bond opens like a bridge. And it's going to grab this guy. So I'm going to write the H on the H. Show the bonds in there. And one of these H's goes here, and the other H goes here. So one H goes here, and the other H goes there. What is this guy's name? My reactant? What is this fellow's name? Ethene, yes. And what is this guy's name? Ethane. Very good. Naming is number 1. Don't go to reactions if naming is not clear in your head. It won't get in. So we go from an unsaturated alkene into a saturated alkane. This is also called a reduction. Reduction, in your products you have more hydrogens. This guy is CH3, CH3. This guy was CH2, CH2. So those two change. You start with an alkene, you end up with an alkane. Ane from an ene. Does that make sense? In order for this reaction to take place, okay, so I need a catalyst, and the catalyst is going to be a metal like nickel or platinum, and you may even see pressure on the arrow. Okay, so on the arrow you're going to see the conditions that need to be met in order for those products to appear. Okay, so you can see nickel in there. Otherwise, it takes forever for the products to be seen. Now, what about if I don't have hydrogen? I have the exact same thing, and I am adding BR. Or I am adding iodine. I2 or Br2. What am I forming? Let's pretend one of these bonds is red. And what's going to happen? 1 Br to each. Okay, so I am going to open up the double bond. Open the double bond. No longer exist in the products, the double bond. They're not there. Okay, so what am I getting? A bromo there and a bromo there, or a what? An iodine there and an iodine there. And whatever else I had, H's, they don't change. Okay, so the other bonds, if I had an H and an H and an H and an H, I still have an H and an H and an H and an H. They don't change. That is called addition, not of hydrogen. When you add hydrogen, that's a hydrogenation. When you add a halogen, it's a what? Halogenation. What about if I add, same guy, I have a double bond, and I'm making a point of showing you the double bond in red and showing every bond. That's the strategy for you to understand. That's not the way the question is going to be posed, but that's where you need to go. What about if I add an HBr? And you know what? I'm going to change this fellow. It's getting boring. This is my longest continuous chain, yeah? So I no longer have a theme to begin with. I have what? What's this guy's name? Propene. And I shouldn't have written him in red. I should have written him in blue, because that's just a parent chain. Okay, so what do I produce here? That's a hydrohalogenation. So I'm adding, and my parent chain, is my parent chain in my product going to have a double bond? No. The H's are not going to be moved whatsoever. But my H and my Br are going to be added. Now this is an unsymmetrical addition. And this is the way it goes. The carbon in the double bond that has the most hydrogens is carbon 1. Do you see that? This guy has 2 hydrogens, 2 hydrogens. This guy has 1 hydrogen. Hydrogens are very friendly. So the carbon with the most hydrogens gets the hydrogen. And the other carbon that has less hydrogens gets the Br. So I'm going to put the H there and the Br there. That's called Markovnikov's rule. Okay? Name this guy. What's this fellow's name? What's this guy's name? 2-bromo what? Propane. And one more. If I have this guy right here, I still have propene, and I add water. And I'm writing water as HOH because I'm showing you the bonds. Your test will have H2O. But you're going to change H2O to HOH to follow what you're doing until you get it, and then you don't have to do all this detailed stuff. Okay, so I'm showing all the bonds and I'm stripping the H's to just address what's changing. Tell me, name the product. I need a little acid. H plus on the arrow means the conditions need to be acidic. I need to add a little phosphoric acid in there in order for my products to appear. What's going to happen? My parent chain is still 3 carbons. Do I have a double bond in my parent chain at the end? No. Where does the H go? To carbon? Carbon 1. Very good. And the OH goes to carbon 2. Name this tune right here. What's this guy's name? We had him earlier. That's H2, that's H, that's H3. What is it? 2-propanol. Very good. 2-propanol is this fellow's name. Not so bad? Now let me give you a funky one. If I got and I'm still being nice, highlighting the red, but I'm raising the bar. The bar will be up. Try to give me the product of that. Okay, so this is still an addition reaction, but now I'm adding water, so let me label. A was hydrogenation, yes, when you're adding hydrogen. B was halogenation, when you're adding a halogen. C was hydrohalogenation, and we said it, but we didn't write it. Hydrohalogenation, because you're adding what? A hydrogen and a halogen. And the carbon with the most hydrogens get the hydrogen. Hydrogens are very friendly, so they mingle. And the carbon in the double bond with the least hydrogens gets whatever else, the bromo or the OH. So what do you need to do in here? You need to show every carbon in the double bond and count what? Count the hydrogens that they have. And if you know how to count all the way to 4, we're going to be good. So if we look at this guy right here, who's carbon 1, how many hydrogens does he have? Carbon 2, how many hydrogens does he have? All the other carbons have 2 hydrogens. And I'm asking you to count to 4. Can we count to 4? Carbon 1 has 1 bond to the methyl. That's 1. 1 bond to carbon 6. 5, 4, 3. And 2 bonds to carbon 2. So does it have any hydrogens? This guy has 0 hydrogens. Did you see that? Because carbon has a valence of 4, and it's taken 1, 2, 3, 4 bonds. It doesn't have a 5th bond for hydrogen. Okay, so carbon number 1 has no hydrogens. What about carbon number 2? Carbon number 2 has what? Has 1 hydrogen. So what's more hydrogens? 1 hydrogen or 0 hydrogens? So who gets the H? Carbon 1 or carbon 2? Carbon 2 that has 1 hydrogen gets the H. Therefore, the OH goes to what? To carbon 1. Draw it. I just dissected it for you. Draw the final structure. hydrocarbon 1 with an OH, and a methyl hydrocarbon 2 with the 2 H's. Okay, and we're going to leave it up to here. Have a wonderful day, and I'll see you next time.